Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, playing with the numbers topic we are going to continue. Our today's concept is least common multiple. It is also called as LCM. LCM, where L stands for least, C stands for common, M stands for multiples. Multiple or multiples, singular or plural we can take. Least common multiple. So the word least common multiple is abbreviated as LCM. Is abbreviated as LCM. LCM. If we have two natural numbers, so then the smallest natural number, which is the multiple of both the numbers. Which two numbers we have taken, for the two natural numbers, the smallest common multiple is called least common multiple. Means, suppose we have a number like 8. What are the multiples of 8? 8 1 is 8, 8 2 times 16, 8 3 times 24, 8 4 times 32. These are all 8, 16, 24, 32. These are all multiples of 8. If we have another number like 4, multiples of 4 are 4 1 is 4, 4 2 times 8, 4 3 times 12, 4 4 times 16, 4 5 times 20, like that. We can have infinite number of multiples for both 8 and 4. Smallest multiple is itself, but largest multiple does not exist, because the number of multiples is infinite. So that's why largest multiple we cannot find. So from these, here if you observe here, this 8 is common in both the numbers, in both the multiples. After that 16 is common. After that 24 will be common. Like that. So 8, 16, 24, these are all common multiples. Out of this 8, 16, 24, out of this common multiples, which one is smallest? 8 is the smallest. Which one is smallest? 8 is the smallest. So here 8 is called lowest common multiple. Means, if you want to find LCM, if you want to find lowest common multiple, first we have to write all the multiples of the given numbers. Not all the multiples, some up to 5 multiples, 10 multiples, like that we have to write. After that, what are common, that we have to make separate. Then out of that common multiples, what is the least? That will be the answer. So for example, if you see here, so consider the numbers 6 and 8. We are considering two numbers. One is 6, another one is 8. Multiples of 6 are 6, 12, 18, 24, 30. How to write multiples, children? Just while writing tables, 6 1 is 6, 6 2 times 12, 6 3 times 18, like that we write. No. On the extreme right side, whatever values we got, they are called multiples. Of the given number. Okay. So we have to write multiples of 6. 6, 12 up to 48 we have written. In the same way, multiples of 8. 8 1 is 8, 8 2 times 16, 8 3 times 24, 8 4 times 32, up to 56 we have written. What are common multiples? 24 is common in both. After that 48 is common in both. What is the least number from common multiples? 24 and 48 are common. From the 24 and 28, what will be the least? 24 will be the least. So 24 is a common multiple and least multiple. Hence it is considered as least common multiple. Least common multiple of 6 and 8 is 24. like that. So very simple, children. You have to understand the concept. Least common multiple. So what we will do? First we will start with M. First we will write multiples. Next what? C. We will take common multiples. Next what? Least. We will take least common multiple. That will be the answer. Next. So another example, children. Consider the numbers 20 and 24. Consider the numbers 20 and 24. Multiples of 20 are 20, 40, 60, 80, 100, 120, 140, 160. Multiples of 24 are 24, 48, 72, 96, 24 5 times 120, 6 times 144, 7 times 168. Okay. So whenever we are writing multiples, we have to write in increasing order. We have to write in increasing order. So what is the first common multiple? 120. Next common multiple will be 240, but always first common multiple will be the least one. So while writing the multiples, as we are writing in increasing order, the first common multiple will be the least common multiple. If we got one, no need to find the other. One is enough. Because we are writing in increasing order, the first one will be the least one. So LCM of 20 and 24 is 120. 120. Okay. But if we have bigger numbers like 8672 or 3400, the LCM of these two numbers, 4-digit numbers. In this method, if you want to find, it will be somewhat difficult. Not somewhat, it will be so difficult. It will be so difficult. Because writing all the multiples in increasing order, again finding the common one, in this method, it will be so difficult one. So, we have two methods. One is prime factorization method. Another one is division method. For what? For finding the LCM of given numbers. LCM of given numbers. Either two numbers or two or more numbers. Whatever given numbers are there. For finding the LCM, we have two methods. Prime factorization method and division method. So next. Prime factorization method. So already in HCF also we have learned this method, children. Prime factorization method. Prime factorization method. So in this method, we write the prime factorization of each of the given numbers. Each of the given numbers. Okay. Next, LCM is the product of all the different prime factors of the given numbers using each common prime factor the greatest number of times. It appears in prime factorization. So let's try to understand the definition with the help of example, children. Suppose we want to find LCM of 28 and 42. 28 and 42. What we have to do? First, we have to do prime factorization. As we have done in yesterday's class, 28, because 8 is even number, let's start with the least prime number 2, 14 times, 2, 7 times. 7 is a prime number which cannot be divided further. So 28 can be written as 2 into 2 into 7. 2 into 2 into 7. 42 can be written as 2 into 3 into 7. All factors are prime numbers. So this is called prime factorization. Okay. Now, prime factorization we have done. So here, the factor 2 is occurring 2 times. 2 is occurring 2 times in the first one, 1 time in the second one. 3 appears 1 time in the second one, 0 times in the first one. 7 appears 1 time in both. So now what is the LCM? We have to take each prime number, greatest number of times, how many times it is occurring, that we have to take. So here 2 times, here 1 time. Which one is greater? 2 times is greater. Here 3 1 time, here 0 time. Which one is greater? 1 time. 7 1 time. which one is greater? 1 time. So whatever common prime factors are there, we have to take them greatest number of times. Greatest number of times. How many times they are repeating? Greatest number of times we have to take. And that product, 2 into 2 into 3 into 7. That product will be 84. And 84 will be the least common multiple of 28 and 42. 28 and 42. Okay. Here in LCM word, L stands for least. But here what we are doing, prime factor, greatest number of times we are taking. Both are reverse. If you want to find LCM, we have to take common factors greatest number of times. If you want to find HCF, highest common factor, or GCD, greatest common divisor, then common factor, least number of times we have to take. Both are reverse. Okay, children. Next. Another example. Let's find the LCM of 36. 36, 40, 126. 36 as prime factors 2 into 2 into 3 into 3. 40, 2 into 2 into 2 into 5. 126, 2 into 3 into 3 into 7. So first we will start with 2. Here appearing 2 times. Here appearing 3 times. Here appearing 1 time. So in LCM what we have to take? Greatest number of times. So which is 3 times. 3 times we have taken. Now 3, 2 times, 0 times, 2 times. So greatest number of times, 2 times. 5 in 36, 0 times. 40, 1 time. 126, 0 times. So 1 is the greatest number of times. 7, 0 time, 0 time, 1 time. 1 time is the greatest. The product of all these 2520, 2520. This is the LCM. This is the LCM. But this prime factorization you have to do first. If you do the prime factorization correctly, then only you will get the correct answer. Instead of prime numbers, suppose if you have 36, if you write like 4 into 9, 4 appearing 1 time, or 40, 8 into 5, 8 appearing 1 time, 4 into 9 into 8 into 5, like that you should not take. You cannot take any number like this. Here we have to do prime factorization. Means 36 to be written as a product of only prime numbers. Even 40 also. Even 126 also. Then only this method we can apply and we can find the LCM. Next. Next children, division method. 1 minute children. Okay children, in this method, we divide the given numbers by a number which divides exactly at least 2 of the given numbers and carry forward the numbers which are not divisible. We keep on repeating this process till no 2 numbers have a common factor. So the product of divisors and the remaining numbers will be considered as LCM of the given numbers. LCM of the given numbers. Okay. So this is the division method. To understand this definition, let's go through this example. Find the LCM of 2024. 20 and 24, we have to find the LCM. So what we have to do for that? For 20 and 24, if we have any common factor, with that common factor we have to divide both. So what is the common factor? 2. 2 10 times 20, 2 12 times 24. So this 10 and 12 we have to keep here. Next, 10 and 12. What is the common factor? 2. 2 5 times 10, 2 6 times 12. Next, 5 6. Is there any common factor for 5 6? No. They are not divisible by any other number other than 1. So, but 1 we should not take here. So, 5 6 are remaining. Now, the product of divisors and the product of remaining terms, it is called LCM. Means the given numbers we have to divide by a number which divides exactly at least 2 of the given numbers. At least 2 it has to divide. Because here 2 elements only are there, it is dividing 2. If we have 3 elements like this, we should check that it will divide at least 2. We have 4 elements, we should check that it should divide at least 2 elements. Like that, we should carry forward until and unless what? Until the remaining numbers, they don't have any common factor. Until then, we have to repeat the same process, division process. If they don't have common term, we will stop there and we will take the product of divisors on the left hand side, remaining terms on the bottom side, and the product of all will be considered as a LCM. So first we have divided by 2, next we have divided by 2, next 5 6 don't have any common term, common factor, so we stop there, and the product of all equals to 120. So LCM of 20 and 24 is 120. Next, so 16, 22, 40. Next one, 16, 22, 40 with 2. 2 8 times 16, 2 11 times 22, 2 20 times 40. Again, 8 is divisible by 2, 20 is divisible by 2, but 11 is not divisible by 2. 2 4 times 8, 4 we will keep here. With 2, 11 is not divisible, so we have to carry 11 like that only into the next step. Next 20, 2 10 times 20. Again 4 11 10, 4 10 divisible by 2, 2 2 times 4, 11 is not divisible, same as it is, 2 5 times 10. Now 2 11 5, they don't have any common factor. We will stop here. Now what is the LCM? Product of divisors into product of remaining terms. 2 into 2 into 2, 2 into 11 into 5. If you do the product, answer is 880. That is the LCM. Next here we have 4 numbers, 36, 96, 108, 160. All are even numbers because in the last digit we have 680. All are even numbers divisible by 2. 2 18 times, 248 times 96, 254 times 108, 280 times 160. Again with 2, 9 times 18, 224 times 48, 227 times 54, 240 times 80. Again with 2, 9 is not divisible, carried like that only, 212 times 24, 27 is not divided, carried like that only, 220 times 40. Again with 2, 9 carried, 27 carried, 2 6 times 12, 2 10 times 20. Again divisible by 2, 2 3 times 6, 2 5 times 10. Now here 9 3 27 we have. After 2, what is the biggest number? 3. With 3 3 times 9, 3 1 is 3, 3 9 times 27, 5 is not divisible, same. Again divisible by 3, 3 1 is 3, 1 same, 3 times 9, 5 same. So here 1 1 3 5, they are not divisible by any common factor. Now product of divisors into product of remaining terms. We can exclude this one no need to multiply, because any number multiplied by 1 will be the same. So while during multiplication 1 no need to count. This all 2s and 3s, this 3, 5. We multiply all, the answer will be 4320. Like this we can find the LCM. Next. Next children, example 3. Find the least number which when divided by 12, 16, 36 leaves a remainder 7 in each case. Means least number dividing these three numbers with the remainder 7. Means that the least number cannot divide these numbers exactly. But it can divide these numbers. Remainder will be 7. Remainder will be 7. Remainder will be 7. Okay. Means we have to find the least number which divides these three and we have to add 7 to that. So then remainder will be 7 because these are not exactly divisible by the least number because the required number we need 7 as remainder. So we will find the least number which when divided by these three numbers, the least number x we will find which when divided by this 12 divided by this 16 divided by 36 leaves the remainder 7. Means if the least number is x, we have to find the least number x such that when divided by 12 remainder 7, when divided by 16 remainder 7, when divided by 36 remainder 7. We have to find that number. But before that we have to find a number which is divisible by 12, 16, 36. For that 7 we will add. So then remainder will be 7. So let's find the least number of this 12, 36 and 16. Least common multiple with 2, 6 times, 8 times, 18 times. With 2, 3 times, 4 times, 9 times. With 3, 1 time, 4 is not divisible, 3 times. Now no common factor, let's multiply all. Let's multiply all. How much? 144. So 144 is divisible by this 12, 16, 36 exactly. Exactly. But we need a number which leaves a remainder 7. But here if we consider 144, remainder will be 0 because 144 by 12, 12 times, complete calculation, remainder will be 0. So this 144 is not our answer because if the number is 144, then it is divided by 12, 16, 36, remainder will be 0. But we need remainder 7. So the least number what we have got, for that we have to add 7. Then if divided by 12 or 16 or 36, the remainder will be 7. So 151 is our correct answer. 151 is our correct answer. Next one. Next. Find the least number which on adding 10 is exactly divisible by 14, 35, 40 and 56. Means the least number, suppose it is x, which on adding 10, we have added 10 to x. So it is x plus 10 is exactly divisible by 14, 35, 40, 56. Okay. Then we have to find the least number. So if we divide by, suppose our number is the least number is x, for that if 10 is added to it, then it is exactly divisible by 14 or exactly divisible by 35, exactly divisible by 40, exactly divisible by 56. If we add 10 to it. Means x plus 10 is exactly divisible by this all these numbers. Means the LCM value will be x plus 10 because x is not divisible by all these numbers. X when added to 10, x plus 10 is exactly divisible by all these numbers. So LCM value will be x plus 10. If you want to find x, least common number, then it should be LCM minus 10. This 10 will come this side, LCM minus 10. Okay, so first we have to find the LCM of all these numbers, 14, 35, 40, 56. With 2, 7 times 14, 35, not divisible. 20 times 40, 28 times 56. With 2, 7 not divisible, carried same. 35 not divisible, carried same. 2 10 times 20, 2 14 times 28. Next with 5, 7 not divisible. Sorry, next with the 2, 7 not divisible, 35 not divisible. 2 5 times 10, 2 7 times 34. Next with the 5, 7 not divisible. 5 7 times 35, 5 1 times 5, 7 not divisible. Next with 7, 1 time, already 1 is there, 1 time. Now multiply all this. Value will be 280. The LCM of all these numbers is 280. Means the number which is divisible by all these numbers is 280. But we need a number which on adding on 10 divisible by all these numbers. But this 280 without adding 10 it is divisible by all these numbers. Means our required number is less than 10 less than this one. 280 minus 10, 270. So our number is 270. If 10 is added to it, it will become 280 and it is divisible by all these numbers exactly. All these numbers exactly. Okay, children. One minute. Next. Find the greatest 4-digit number which is exactly divisible by 12, 18, 30. So we have to find the greatest 4-digit number exactly divisible by all these numbers. So first we have to find LCM of 3 numbers. Like this, LCM already we have done in so many examples. LCM, product of common factors which are repeated greatest number of times, or all this we have to multiply, 180. But we need 4-digit number, greatest 4-digit number. It is the least common multiple, 180 we have got, but we need greatest 4-digit number. So actually the greatest 4-digit number is 4 9s, 9,999. Let's try to divide this with this LCM, 180. So 180 5 times 900, 999, 5 times 900, 99 is remaining. 99 is remaining. Means when we divide 9,999 by 180, we got remainder 99. 99. Means this 9999 is not divisible by 180. But if we remove this 99 from 9999, if we remove this 99, because 99 is the remainder, then this 9900 is exactly divisible by 180. 180 is what? 180 is the least common multiple of 12, 18, 30. So 9990 is can be divisible by 12, 18, 30. 12, 18, 30. Okay, Jira, next. Find the smallest number of 5 digits which is exactly divisible by 15, 24, 40. So here smallest number of 5 digits we have to find. Here greatest number of 4th digit is 9,900. In the same way, here smallest 5 digit number we have to find. Let's find the LCM of given numbers. LCM of given numbers 15, 24, 40. 2, 15 same. 2, 12 times 24, 20 times 40. Which 2? 15 not divisible, same. 2, 6 times 12, 2, 10 times 20. Next, which 2? 15, same. 3 times 6, 5 times 10. Again with 5 or 3. 3, 5 times 15, 1, 5. Again with 5, 1, 1, 1. The product of all this. How much? 120. 120 is the LCM. 120 is the LCM. But we have to find the smallest number. 120 is the LCM. We have to find smallest 5-digit number. So let's divide with the 120, smallest number, 1 lakh. So remainder what? Remainder 40 we are getting. Remainder 40 we are getting. Remainder 40 we are getting. So what we can do here? Here we need a smallest number, which is divided by the LCM. Exactly, it should be exactly divisible by 120. Sorry, children, here 120 it is. So, but this 1 lakh is not exactly divisible by 120. So, because 40 we are getting remainder. If we have 40 less here, means 99,960. It is sorry here 5 digit means it is 10,000 actually, not 1 lakh. 10,000. 10,000 is not exactly divisible because 40 is remainder. If we remove 40 from 10,000, 9,960 is exactly divisible by 120. So next, what number will be divisible by 120? We have to add plus 120 because next multiple of this. If we add plus 120, then we will get the next number. Means for 9960, we have to add 120. So then what it will become? 10,080. 10,080 is the smallest 5-digit number divisible by this all these numbers or 120. Or else what we can do means this from 10,000 already remainder we got, already remainder 40 we got. From for 10,000 we can add this 120 minus 40. So then also we will get the answer 10,080. So this is the smallest 5-digit number divisible by all these numbers exactly. Okay, children. So next we will continue in next class, children. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.